All right, all right, all right. Algebra 1, folks. Thank you for hopping into today's lesson, lesson 16. We have linear inequalities in today's lesson. This is actually your last new lesson before your nice Thanksgiving break for everybody. So let's finish on a high note. Things are going to look a little bit different once we return from Thanksgiving break with the remote 2.0. We have a very organized system, so I'm not worried about things. I'm bummed that I'm not going to see you face to face. I do think this is the best decision for us to get healthy and be able to return to a normal school like how we know it before this year. But regardless, we're going to keep kind of this routine of we'll have video lessons. We'll have daily live sessions that you guys can work with us. And I'm going to really start encouraging people to use Desmos as one of their choice activities. You can always share your problems with us on the screen. We can work on them together. You don't have to worry about paper. You can just do your work on a separate paper, and then your answers get submitted right in. Highly encourage you to keep using that or to try using that. But let's hop into today's lesson. Today's lesson is about linear inequalities. I'm going to start right here. It says, now that we are comfortable graphing linear equations from last week, it only makes sense that we change the equal sign to an inequality and graph that as well. Okay, sorry, that is some terrible handwriting in that one. That says inequality and graph those as well. So if we can graph equations, we can certainly graph inequalities. There's just going to be a little extra step at the end. Okay, well, what is a linear inequality? Just for the sake of keeping it easy, it's like a linear equation except no equal sign. And we're going to see one of these four, which you've seen before. We saw earlier this year, and you saw even before this year. They have less than, greater than, less than or equal to, greater than or equal to symbols. We're going to see one of those four. Okay, one of the first things that we did with two variable equations was we wanted to check for solutions. We were trying to get to a point where we made a decision on something like this. Does 3 equal 5? And if 3 didn't equal 5, which it doesn't, we would say whatever point we were given. An example, it might have been like the 0.24. We plugged that in and said, is that a solution? We would say, no, this is not a solution because this is not true. Only difference now, no equal sign. We see that this one has a greater than symbol and this one has a less than or equal to symbol. So instead of trying to figure out are things equal, right, we're trying to figure out are they maybe greater than? Is one side greater than or is one side less than? We just want to pay attention to that. Let's hop right in here. Here's the first thing. It says determine if the given point is a solution to the given inequality. Here's our point and here's our inequality. Well, the first thing it gives us is an ordered pair, this point, this negative 1, 3. We know that that's an xy pair. That's x and that's y. So I need to substitute this x in for this x and this y in for this y and then just do a little bit of math. So instead of saying 5 times x, it's going to say 5 times negative 1 minus 3. Instead of saying 3 times y, it's going to say 3 times 3 is greater than 1. I'm just copying this side down. Let's do a little bit of math. 5 times negative 1 is negative 5. Negative 3 times 3 is negative 9 and is greater than 1. Okay, more to simplify here. Negative 5 minus 9 is negative 14 is greater than 1. Read that statement. Is negative 14 greater than 1? That should seem strange when we say it because it's not true. That is not true. Well, what does that mean? That this point that it gave us, we can say negative 1, 3 is not a solution. Okay. Simple as two variable equations, just no equal sign. All right, let's hop into example B. If you want to pause it, try it on your own, separate sheet of paper, and then see how it went. Definitely a good idea. So we have this point 0, 1. This is our x, this is our y, and we need to go ahead and plug those in for x and for y and then check it. So now instead of saying 3 times x, it's going to say 3 times 0, minus instead of saying 2 times y, it's going to say 2 times 1. And this says is less than or equal to 5. Let's check it. 3 times 0 is 0. Negative 2 times 1 is negative 2, is less than or equal to 5. 0 minus 2 is negative 2, is less than or equal to 5. What does that mean? Negative 2 is less than or equal to 5. Is that true? Yes, it is. Right? So what does that tell us? It tells us the point that it gave us. Right? This 0, 1, we can say 0, 1 is a solution. Okay, pretty basic. I'm going to keep it at those two examples. We should be able to be fluid if we ask you about an equation or an inequality, finding out if it's a solution or not a solution. We should be able to plug it in, do a little bit of math, and answer that fairly quickly. Here's where we're going to start to see a difference, okay? It says, as with linear equations, we have an infinite number of solutions. A major difference here, right, is that with an inequality, it's that our solutions are not ordered pairs just on a line, but now we have an entire section of the coordinate plane. I'm going to give you a very basic example. Okay, here's my example that I think can be the most basic. We used to have things like this, y equals x plus 3. And we would get a coordinate plane, and we know that this graph started at positive 3, had a slope of 1 over 1, and ran like this. And all of our solutions were on this line here and here, here. All the solutions, if I checked those, they would come out as true. It would say something like 7 equals 7. Yes, it is a solution, right? All our solutions were on the line. Now we don't have an equal sign. We have something like this. Y is less than x plus 3. So we get a graph again. We still have a y-intercept of 3. We still have a slope of 1. So it's a very similar looking start. We're going to see some things now that are like dotted lines. I'll get to that in a little bit. But now it says what's less than that. So I'm looking for which of this side. Is it this side? I'll call it red. And I'll call it green. One of these two areas of the whole entire coordinate plane is all of our solutions. They don't just fall on this line anymore. They fall either above it or below it. We need to find where are the solutions. They're a big piece, either this piece or this piece. That's what we're going to see down below. Okay, so that's kind of what I want your mind to be focused on. I think it's 3 pretty easy steps. So I'm going to, let's keep rocking this purple here. I'm going to go down and show you what these 3 steps are. The only way to find the solutions is graphing it. So we have these 3 steps below. First step, replace the inequality symbol with an equal sign. I'm going to tell you why that's best for us in a second. Then graph that equation. Then pay attention to this. We're going to draw a dotted line on our graph if we get one of those 2 symbols. And we're going to draw a solid line for one of those 2 symbols. So when we're ready to graph, we just need to pay attention to that. And then it says 3. This is important, very important. This is finding our solutions. Test a point not on the line. I want you to write this here, 0, 0. That's the easiest point when we can use the number 0. 0 is easy to work with. It's just very convenient. My teacher taught it to me. I figured it'd be a good strategy to pass down. It says if that point satisfies the inequality, so really if it makes it true, shade that portion containing the point. If not, shade the other portion. I'll give you an example to see what that looks like here in just a moment. Let's dive into A, and we're going to follow these 3 steps. Read step 1 again. Replace the inequality symbol with an equal sign. Okay, so now we have, now we have x plus y is less than 3. Now we're going to write this x plus y equals 3. Okay, so we just replaced it with an equal sign. I need this, y equals mx plus b to graph. We just like that one better. I don't have that yet. I need y alone. So I need to get y alone. How do I do that? Move my x. Excuse me. X minus x is 0. It goes away. So I am left with y equals 3 minus x. Those are not like terms. I'm just going to write out negative x plus 3. Now I'm ready to graph because I have something in slope-intercept form. This 3, my y-intercept is a positive 3. 1, 2, 3. There's my 3. That's I got from here. And then this is my rise over run, my in front of my x term. I don't see a number, but I know that's a 1. And anything can become a fraction by putting it over 1. So it's saying my slope is negative 1 over 1. So down 1 to the right 1. Down 1 to the right 1. I'm going to do that a handful of times. And then I'm going to go to step 2, right? It says graph the equation. And then it says pay attention to the symbol. For these 2 symbols, a dotted line. Well, that's what we have. We have just a less than symbol. I'm going to draw a dotted line. Let's see if I can do my best here. Okay, I've drawn my dotted line. Now I need to test that inequality with a point, any point on the graph. We get to pick it. Let's pick 0, 0, I told us, right? So I'm going to test the point 0, 0. What does that point look like when I write it out? It just looks like this, 0, 0. That's my x, that's my y. And plug that in here. So now instead of x plus y is less than 3, I have 0 plus 0 is less than 3. Well, 0 plus 0 is 0. Is 0 less than 3? This is what I'm judging. Yes, it is. Right? That's good news. Here's where the point 0, 0 is, the origin. That's why we picked it. And that's where a solution is. So that means all of the solutions, we just shade this whole area underneath this line. That means none of the solutions are over here. You don't have to draw this X. I'm just showing you visually. No solutions are there. I'm going to prove it to you. Here's the point. Here's the point. Let's go 4, 4. 1, 2, 3, 4, 1, 2, 3, 4. That point right there. I'm going to test that point. 4, comma 4. You don't have to do this if you don't want. So now instead of X plus Y is less than 3, it's going to say 4 plus 4 is less than 3. 4 plus 4 is 8. 8 is less than 3 is not true. This is not a solution. So I don't shade any of that area. All of this area are the ones that aren't solutions that make that inequality true. And this whole purple area are solutions. They do make it true. Okay, let's jump into the second example over here. I'm going to clear a little bit of space for us. This next one says 3x plus 5y is greater than or equal to 15. Up above, remember, step 1, replace the inequality symbol with an equal sign. So now I have this, 3x plus 5y equals 15. I need to get y alone for slope-intercept form. That means minus 3x, both sides. 5y equals negative 3x plus 15. Divide this by 5. Divide this side by 5. 5 divided by 5 is y. Negative 3 divided by 5 is going to give us a decimal. We like fractions here. We like rise over run, right? Our rise on top, our run on the bottom. So let's just leave it as negative 3/5 x. And then 15 divided by 5 I can do. That's a positive 3. So now I have this ready to graph. I have, again, a y-intercept of positive 3. I see that right here. And then I see a rise over run of negative 3 over 5. So it's saying go down 3 and to the right 5. And I have my 2 points there. Now, step 2, when it says graph, pay attention. What do I want, a solid or a dotted line? Well, look at this symbol. The symbol means draw a solid line. I remember it because the symbol has a solid line underneath it. So I'm going to go ahead and draw a solid line. And then I want to test a point. Step 3, test a point. It doesn't tell us what point to test. It says test a point. Let's use that 0, 0 again. Just make that kind of your go-to. You're going to notice it just makes our numbers small. Small meaning normally 0. And we can figure out if that statement's true or not. This eraser's going very slow here today. I apologize. So let's check that out. I'm going to use the point 0, 0. So instead of saying 3x, it's going to say 3 times 0 plus 5 times 0 is greater than or equal to 15. I'm testing this point here to figure out if that's where I should shade, if that's where the solutions are. 3 times 0 is 0. 5 times 0 is 0. Is greater than or equal to 15. 0 plus 0 is 0. Is greater than or equal to 15. Read that statement. 0 is greater than or equal to 15. That is not true. So this is not a solution. So these, these are not the solutions. These are the solutions. The other side of that line are all the solutions. Okay. When I tested that point 0, 0, it didn't work. It did not make a true statement with that inequality. Last but not least, though, I have some of this work here already. I forgot to clear this from earlier. Let's go ahead and do a little bit of work here. Get rid of this. I'm going to clear this guy. Thought I had this out of here. Take a second to collect your thoughts. We're going to do example 6. Example C. I'm losing my mind here as we near the end of these notes. It looks a little sloppy, but we've got most of the stuff out of the way that we want. All right, let's hop up to C. C says x minus 3y is less than 6. First thing was replace it with an equal sign. X minus 3y equals 6. I need to get y alone. Minus x. I get negative 3y equals negative x plus 6. Divide by negative 3. Divide by negative 3. I'm going to get y equals... Negative divided by negative is a positive, and that's a 1/3. That'd be a decimal. We like the 1/3 instead for rise over run. And then 6 divided by negative 3 is negative 2. So let's copy this guy down below because we need to graph that. Y equals 1/3 x minus 2. For that, I'm going to now graph that. I have a y-intercept of negative 2. And I have a rise over run, rise of 1, run of 3. Do that a couple times. I have that there. Then I need to go look, what kind of line do I need? Solid or dotted? Here's this. What do I need? I need a dotted. And draw a dotted line here. Let's test the point. We love the point 0, 0. Our original equation was x minus 3y is less than 6. So let's plug our zeros in. 0 minus 3 times 0 is less than 6. 3 times 0 is 0. So 0 minus 0 is less than 6. 0 minus 0 is 0. Is 0 less than 6? Yes, it is. Where is that point? We tested that point's right there. That means all the solutions are on this side of the line. To summarize this lesson, we want it to be slope-intercept form to graph. We want to make sure that we test a point. If you don't like 0, 0, pick your own point. I like it because it's simple. And then if that's true, that point and that side of the line is where all the solutions are. For the sake of remembering, these two symbols create a dotted line, and these two symbols create a solid line. I remember that because, again, these have solid lines and these don't. And that's it. This is one of our last lessons of two variable equations. Let's finish it strong, and remember to consider Desmos or Delta Math is a great one to check out for today's lesson. I will talk to everybody soon. Thanks for hopping into today's lesson.